Welcome to this session. In this session, we are going to talk about data science. We are going to introduce to you data science and why is it so important and what are the nuances which you need to keep in mind if you are thinking about a career in data science. First of all, let us understand that why is data getting noticed everywhere? What is all this buzz around big data? So if you would see from the graph, you would see that the data volume is huge, and it is not only huge, but it is also increasing at an exponential pace. Just for the matter of fact, in 2018, the global data volume stands at approximate 25,000 exabytes, and 1 exabyte is equal to 1 million terabytes. So you can understand the humongous nature of the volume of data available out there. 25,000 into 1 million terabytes. So that is the volume of the data we are talking about, and this data is almost increasing at a 40% CAGR year on year basis, and that is where data becomes so critical, and that is where it is very difficult for any organization to let the data go unnoticed. Now, when we talk about data, there are four V's of big data which we can talk about. The first one is the volume, that is, what are the different sources which are generating this data. This data is coming through the information from sensors, browsing history, social media platforms, different logs of conversations, events, speeches, images, videos, and so many other traditional ways of exchanging information or exchanging data, that all these sources are contributing to the huge volume of data which we are generating today. The second aspect, the second V of big data is veracity, that is the accuracy and the cleanliness of the data. So today, if I consider the huge volumes of data which are coming in, most of them are unstructured and unclean. And that is where the role of the data scientist comes into picture to work on the veracity of the data. Third is a velocity. When I say velocity, we discussed in the previous slide as well that the speed at which this data is getting generated is humongous, it is unmatchable, it is exponential. And that is where I need to enhance my speed, enhance the efficiency of my automation processes to analyze this data. And lastly, it's not just the volume and the pace at which this data is being generated, but the fourth V of big data talks about variety. This variety tells me that the data which we are getting through all these different resources, it is almost unstructured or semi-structured or structured. So when I say structured, I basically mean that the data which is structured is stored in a proper database like RDBMS. Or say when I am talking about semi-structured data, this is the data which I am getting in some XML files, Excel files, Word documents. Those are the semi-structured data. And then third is the unstructured and the loosely available data. Now, unfortunately, the percentage contribution of unstructured data across the volume of the data is highest, and the least percentages of structured data. Now, if that is the volume of the data, that is the issue with veracity, that is the velocity of the data, and those are the kinds of variety which we expect in big data, then we certainly need data science to decipher information, to decipher meaningful insights from this data. So when I say that big data needs data science, the rationale behind that is today we have huge collection of data with volumes spread across multiple devices and formats, and these data are stored in numerous distributed systems and machines, and technically, in technical terms, we call these distributed systems as Hadoop clusters. So Hadoop clusters are nothing but the distributed systems in the machines in which this humongous data is stored. Now, what does data science do? Data science extracts information from this big data, and it comes up with a meaningful insight and information which could drive the strategy of the organizations in multiple forms. Now, let us have a look at what is the theoretical and exact definition of data science. Now, there are multiple sources, there are multiple people who have defined data science in different ways, but the core of all those definitions remain the same. Let us have a look at some of the data science definitions. The first data science definition says that it is an automated way to analyze enormous data and extract information. This is precisely what we have been saying in layman's terms so far in this video. That data science helps me to automate things, to analyze and extract information from the data. Another definition of data science says that data science is a powerful approach to make new discoveries from humongous data. Again, this is something which is very easily understandable and relatable to the previous definition of data science. Last and the most popular definition of data science states that data science is the new discipline which combines the power of statistics, mathematics, programming, and visualization to transform data into information. So, this is the most popular and widely used definition of data science, which captures each and every essence of data science in it very beautifully. Now, there are broadly two components of data science. One could said to be technology tools, and the other could said to be domain expertise and scientific methods. Let us first of all see what all falls under domain expertise and scientific methods. Scientific tools and methods which we have been talking about, they fall under this category. Then the different mathematical models and statistics. So data scientists, they would collect data, explore it, analyze it, visualize it. They would use concepts like mean, median, mode, standard deviation to test a hypothesis, or say to create a new hypothesis based on the data they are analyzing. So once you are done with the domain expertise, Python, as we said, is the driving language in terms of technology for ACE in data science. Second is the extensive set of libraries, which are nothing but inbuilt functions, which act as a technology tool to form the component of data science. Then there are multiple data processing tools which get into it. Then there is application design, which is basically the user interface side and how the application looks at the front end. And then there are the plethora of operating systems. Now, as we discussed earlier, Python is independent of the operating systems. It could very easily work across. Now, we talked about data analysis. Let us see that what are the different types of data analysis which are available out there today. The first kind of data analysis is descriptive. In descriptive data analysis, I basically study a data set to derive some set of details or information from it. I basically use an existing data set to decipher the details. That is what is descriptive analysis. Second is predictive analysis. Here, I create a model based on existing information to predict the outcome in future. That is predictive analysis. And then the third is prescriptive analysis. In prescriptive analysis, I suggest actions for a given situation based on the collected information. Just like the prescription of a doctor, this is the prescription of a data scientist who suggests actions based on the collected information for a specific situation. Now, how do technology tools help? The major help which technology provides to a data scientist is to build machine learning models where the machine is being made intelligent in itself to partially or fully automate the process of data analysis, exploring, visualizing, and finally arriving at a useful information. Second is technology tools, they help me to manipulate data and extract information from it. And lastly, once I have processed the entire data using technology tools, I can finally build my own data tools, applications, and services. That is how much is the scope of technology tools into data science. I can ultimately build my own data tools, applications, and services. Now, having discussed that what is data science, let's try to have a look at the typical workday for a data scientist. It obviously starts by asking a question for a given situation. This question could be posed by the organization or could have proactively come in the mind of the data scientist. Now, once he has a question, he moves towards acquisition of data where he is going to collect data from multiple sources. Now, data acquisition is the first step which he would take based on the question put forth to him. Once data is acquired, data wrangling is done. Data wrangling is basically where the data is going to be processed, a lot of technology tools are going to be used, and things like data cleansing, data manipulation, data discovery, all would be done at this phase of data wrangling. Once it is done, then a lot of statistical models are applied on this analyzed and worked upon data. The statistical models are going to be applied, and when they are applied, the final report is generated, and we move towards the data visualization part where the data scientist is going to tell you a story in a very visual form such that the data appeals to everyone, and a data driven visualization, a data driven intelligence would be provided. Now, based on this, I could build certain data products. That is what a lot of organizations do today. That once all the statistical models and the technology tools have been applied on the data, they finally build their data products. And whatever information comes in the data products, whatever comes as the input, whatever goes as the output, everything keeps on getting into the machine, so that machine can continuously learn and things could be automated in the favor of data automation, uh, be it semi or fully. So this is how the typical workday for a data scientist works. We have talked about data scientists, we have talked about its workday, but this is a time we should also talk about the kind of skills which a data scientist needs. First of all, he should have a good domain knowledge. If he does not have a domain knowledge, how could he analyze data and how could he come up with something strategic in nature based on the information provided to him after the entire process of data science? And hence, domain knowledge is very important. Second is, data scientists should have the ability to ask the right question. Unless you ask the right question, you won't get the right set of data. Unless you get the right set of data, you would not be able to arrive at the intended outcome of the entire process. Then he should be able to understand the data structure. That is another important skill which a data scientist should have. Fourth is he should be able to interpret and wrangle data. Virtually, he should be able to play with data at his choice, at his will. He should be able to just play around with data. And he should have the ability and the acumen to apply statistical models on data. And once he has applied all the statistical models, he should have the ability to visualize data, and not only visualize for himself, but communicate the arrived information, the arrived intelligence, the arrived insights with different stakeholders of the organization. And last but not the least, he should have some basic understanding of programming in either Python or R. Now, since in this course we are going to focus on Python, so yes, Python is one of the skills which a data scientist needs to have at least at the beginner's level. With this, we come to the end of this session and we would meet again in the next session. Thank you, everyone.